Hi guys! Welcome to my class. Our topic for today is about rhombi and squares. But before we proceed, let me tell you about Baba Zayed. When Sheikh Zayed became president of the UAE in 1971, one of his first actions was to guarantee that his children would live securely, happily, and comfortably forever. Look at the UAE before. Sheikh Zayed knows the difficulty of his people. He is concerned about the economic and social situation of everybody here. And this is why he took ingenuity and leads to develop the social, economic, and physical situations of all the people living here in the UAE. His commitment to the Emiratis was incomparable. He continued to offer all they could ever need, as a father would do to his children. That is why all the people call him Baba Zayed. When some people ask him if he is bothered that his action may cause his people to become too dependent on him, do you know what his reply? He told them, "My wealth is for my children." Look at the UAE now. From free housing and education to subsidized even food, Sheikh Zayed built this nation into a prosperous state. Under the leadership of Sheikh Zayed, this inspires all the people and everybody that surrounds him. That is why the UAE experienced exponential growth. Being a good father and the best leader, Sheikh Zayed continued to revive the new generation by setting an example of going for challenging goals. You see guys, Sheikh Zayed did not stop to achieve what he wants so that his children will live comfortably ever. What's interesting is the current leaders of the UAE is also the same as him. Are you inspired again by Sheikh Zayed? Now, let's move to our lesson. To recognize and apply the properties of rhombi and squares. A rhombus is a parallelogram with all four sides congruent. And it has all the properties of a parallelogram. In Theorem 11.15, if a parallelogram is a rhombus, then its diagonals are perpendicular. So, if parallelogram MATH is a rhombus, then line segment MD is perpendicular to line segment HA. In Theorem 11.16, if a parallelogram is a rhombus, then each diagonals bisect a pair of opposite angles. I want you to look at the diagram. So, if parallelogram MATH is a rhombus, then the measure of angle 1 is congruent to the measure of angle 2. The measure of angle 3 is congruent to the measure of angle 4. The measure of angle 5 is congruent to the measure of angle 6, and the measure of angle 7 is congruent to the measure of angle 8. Let us try to work on this. The diagonals of a rhombus SMTR intersect at point A. If the measure of angle MTR is equal to 85, find the measure of angle ART. Look at the diagram. It shows that the diagonal ST bisects angle MTR. Therefore, the measure of angle ATR is half of the measure of angle MTR. By substituting the value of the measure of angle MTR in the equation, therefore, the measure of angle ATR is half of 85, which will give us 42.5. Since the diagonal of a rhombus are perpendicular, therefore the measure of angle TAR is equal to 90 degrees. That is the definition of perpendicular lines. I want you to look at the diagram again. We are going to solve the different measure of angles which I designated with color red, green, and blue. So, those angle is equal to 180. As we have learned before, the measure of the interior angles is always supplementary, 180 degrees. The measure of angle ATR plus the measure of angle TAR plus the measure of angle ART is equal to 180. So, substituting the given values in the equation, 42.5 plus 90 plus the measure of angle ART is equal to 180. Simplifying it, we can come up with 132.5 plus the measure of ART is equal to 180. To eliminate 132.5 on the left side, we are going to subtract 132.5 on both sides. And it will give us the measure of angle ART, which is 47.5. What about this problem? The diagonals of rhombus SMTR intersect at point A. If line segment SR is equal to 2x plus 7 and line segment RT is equal to 4x minus 3, find the x. Since the diagram is a rhombus, by definition, all sides of a rhombus are congruent. Therefore, line segment SR is congruent to line segment RT. By the definition of congruence, SR is equal to RT. We can substitute the given values in the equation and we can come up with 2x plus 7 is equal to 4x minus 3. To eliminate 2x on the left side, we're going to subtract 2x on both sides. And we can come up with 7 is equal to 2x minus 3. To eliminate 3 on the right side, we're going to add 3 on both sides. And we can come up with 10 is equal to 2x. To find the x, we're going to divide both sides by 2. And it will give us x is equal to 5. What about this one? MATH is a rhombus with diagonals intersecting at point S. If the measure of angle MAH is equal to 2x plus 3 and the measure of angle HAT is equal to 3x minus 24, find the measure of angle HAT. The measure of angle MAH is congruent to the measure of angle HAT. This is alternate interior angles, and in a rhombus, they are congruent. Substituting the given values in the equation, it will give us 2x plus 3 is equal to 3x minus 24. To eliminate 24 on the right side, we are going to add 24 on both sides. And it will give us 2x plus 27 is equal to 3x. To eliminate 2x on the left side, we are going to subtract 2x on both sides, which will give us x is equal to 27. To find the measure of angle HAT, we are going to substitute 27 in the given equation 3x minus 24. It will give us 3 times 27 minus 24. So, the measure of angle HAT is equal to 57 degrees. A square is a parallelogram with 4 congruent sides and 4 right angles. But a parallelogram with 4 right angles is a rectangle. And a parallelogram with 4 congruent sides is a rhombus. Therefore, a parallelogram that is both a rectangle and a rhombus is a square. I want you to look at the Venn diagram here so that you can see the relationship between the square, the parallelogram, and the rhombi. Look at the rhombi. We have 4 congruent sides, and a square have 4 congruent sides. Parallelogram, we have 4 congruent angles, and the square has 4 congruent angles. Now you see the relationship? On conditions of rhombi and squares, in Theorem 11.17, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Look at the diagram. If line segment MT is perpendicular to line segment HA, then parallelogram MATH is a rhombus. On Theorem 11.18, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. I want you to look at the diagram again. If the measure of angle 1 is congruent to the measure of angle 2, the measure of angle 3 is congruent to the measure of angle 4. The measure of angle 5 is congruent to the measure of angle 6, and the measure of angle 7 is congruent to the measure of angle 8. Then the parallelogram MATH is a rhombus. On Theorem 11.19, if one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. So, if the measure of line segment MA is congruent to the measure of line segment AP, then parallelogram MATH is a rhombus. In Theorem 11.20, if a quadrilateral is both a rhombus and a rectangle, then it is a square. Look at the characteristic of a rhombi. It has 4 congruent sides. And the characteristic of a parallelogram, they have 4 congruent angles. And the square have 4 congruent sides and 4 congruent angles. Let us work on this example. MATH is a square. Line segment MS is equal to 5x plus 8, and line segment HS is equal to 6x minus 2. Find line segment AH. We can come up with line segment MS is congruent to line segment HS because it is a square. Substituting the given values in the equation, 5x plus 8 is equal to 6x minus 2. To eliminate minus 2 on the right side, we are going to add 2 on both sides. And we can come up with 5x plus 10 is equal to 6x. To eliminate 5x on the right side, we are going to subtract 5x on both sides. And we can come up with x is equal to 10. To find line segment AH, we can use the line segment addition. So we can use line segment AS plus line segment HS. But line segment AS is also equal to line segment HS. So we can add HS plus HS will give us 2HS. By substituting the given values of HS, we can come up with 2 times 6x minus 2. And substituting the given values of x to the equation, it will give us 2 times 6 times 10 minus 2, which will give us 2 times 58. Therefore, the line segment AH is equal to 116. As I am always telling you guys, I will never stop reminding you what Sheikh Zayed wrote for us. Education is like a lantern which lights your way in a dark alley. Whenever you are confused on some part of the lesson, I want you to go back. Light up your way, watch it again, step by step, closely, carefully, and slowly. And I know you will get it. Math will always be easy for those who are studying. Try to discover your undefined smartness. Score high in math. Okay, guys? Good luck! God bless!